You've already learned how to use the trig ratios, the tangent trig ratio, which we use when you have the opposite side of a right triangle and an adjacent side. Let me repeat, tangent is for opposite and adjacent sides only. It relates them as tangent of an acute angle equals the opposite side to that acute angle divided by the adjacent side. The sine and cosine, in contrast, involve the hypotenuse and a leg. The hypotenuse and a leg. So let's look at angle A here and angle A and angle A. This is these are identical triangles. So in the first one, we're going to focus on sine of A, or we can say sine of angle A, cosine of angle A. Sine of angle A is opposite over hypotenuse. So what's opposite to A? Look, A, and that is BC, and oh, I did forget to write A. So sine of A is BC over the hypotenuse. The hypotenuse is always the hypotenuse. It is opposite the right angle. Hypotenuse, hypotenuse. So sine of A is BC over AB. Cosine of angle A is adjacent over hypotenuse. So what is adjacent to angle A? Adjacent to angle A, if I draw this arc, that arc touches the hypotenuse and the other side it touches is AC. So this is adjacent, and cosine of A is adjacent, which is AC over hypotenuse, which is AB. So let's label this hypotenuse. Hypotenuse, this is opposite to angle A, and this is adjacent to angle A. So sine and cosine respectively are ratios of the opposite side to the hypotenuse side, and cosine is the adjacent side to the hypotenuse. Again, it's a ratio, so sine of A and cosine of A will be numbers, and we look at that in this problem. So you want to find sine of S. Let's say sine of S, that's opposite to S is 63, which you see here. And then the hypotenuse is there, and similarly for cosine. And you say that the sine of S or the sine of R is equal to a ratio of two numbers which can be converted to a decimal. It is convention that when you use sine of S and sine of R, you use at least 4 decimal places, or at least you use 4 decimal places. What I'd like you to do is make sure that you watch the 2 videos on using trig functions on your calculator before you start to do these problems. Trig functions are used to find heights and distances when you know the angle of elevation or depression. So what is it? Pretend that this is the ground. And your eye is looking up at an object here. So we can just say that's a ball that's flying, or it could be the sun. How about the sun? That's the sun. So your eye is looking up at the sun, and this is the angle of elevation. So I'm going to write that here, angle of elevation. It is always made with the horizontal. It's when you're looking up at an object. If I was looking at the top of a building, let's say, I'm going to do that over here. This is a building, and this is the top of the building. The top of the building is top of building. And I knew this angle was 20 degrees, and I knew this was 500 feet. Then I could say tangent of 20 degrees equals h over 500. What this allows me to do is solve for the height of the building by just measuring the angle of elevation. And you would do h equals 500 times 10, 20 degrees, and using the calculators on the videos for using calculators. There are 2 videos. Make sure you watch those. Next, angle of depression. Okay, this time let's say you are in a boat. Oops. Let's try that again. You are in a boat. So this is my boat. Okay, and you're looking down at a fish in the water, or you could be at the top of a mountain looking down. This is your fish. Let's give it a little eye here. Oh well, it's the best I can do. This time you are going to be looking down at the fish. Once again, your angle is made with the horizontal. So this is angle of depression. If you knew this angle and you knew this distance, you would be able to find this using trig functions. Anyway, you're going to see some examples below. These are pretty simple, and you can look at the example above. This one too is just calculated. Let's look at this one. It says a rope stick 20 feet from the base of a building goes to the roof and forms an angle to the nearest tenth of a foot. How long is the rope? The important thing here is finding out where is the rope, and this is the rope. So that would be your distance off that you want to find. So I would call it R, and oops, you will be finding R. Okay. Next problem. It says a pilot is looking at an airport from her plane. So let's say this is the plane here. Now I'm not very good at drawing, but so I'm going to write the word plane. Plane is over here. The altitude is 10,000 feet. So altitude is the height. That's 10,000 feet. Okay. The angle of depression. Now you're going to ask yourself why you've got the 29 here, and I'm going to just remind you that the actual angle of elevation is 29 degrees here as the pilot's looking out, but these are parallel lines. The ground is horizontal, and so is, the line that you make the angle of. So these two angles are congruent. Therefore, you have 29 degrees here, and you want to know how far the plane is from the airport. So the distance you are going to find not at all. Let's erase that. The distance you are going to find is x. Okay, Okay, ignore this highlighter. So you are going to find the distance x. Let's reinstate that right angle back in there. Okay. Dog is looking at a squirrel at the top of a tree. So this is your squirrel and this is your dog. Okay, so this is going to be 64 degrees. So you need to find x and y. You're going to set up your relationships and go ahead and do that. That shouldn't be a problem for you. Okay, good luck with the problems. Your answers are here, so go ahead and check them after you are finished. Let's just label the problem numbers. This would be 1. This is 2, 3, 4, and 5, and the answers here are 1, 2, 3, 4, 5. Okay, okay. All right, good luck.